So, hello everyone, I am Rohan and I would like to share you an incident in which we solved a problem very patiently. So, it was a Cloud Impact Lab hackathon at Mumbai, and we were given the problem statement of finding the missing peoples in Kumbh Mela. Kumbh Mela is basically the biggest religious gathering in the world, and there tens of thousands of people get lost every year. And so to solve this problem, most obvious thing was that everyone will implement the YOLO model, and they will basically go the facial recognition way. But the main issue is when a child gets lost, not just the camera scans not just the child but also the people nearby it. So the model is too vague and it had multiple inaccuracies. And when we talk about the real facial recognition at ground level, we don't know who the peoples are. We couldn't fetch the data from Aadhaar card, that is unique identification number for India, because that will affect the privacy concerns of the program. So what we done is we done pattern recognition, we done pixel recognition, and we done garment recognition. So while doing this, we use ResNet 50 and MobileNet V3, and our accuracy surpassed the whole huge models of 20-30 GBs, YOLO and fine-tune models. That is why we won the hackathon. So yeah, what we have done is our optimized model was able to run on a small Raspberry Pi and even a big computer. At the level where we have to scale this model at the given budget constraint, it is the most optimized way to run the model on Raspberry Pi. So here we were like the best and optimized option for the judges. So yeah, we won the uh, competition. Again, I would like to tell you about what we are developing currently. I am developing some financial solutions, and we do get some false negatives and false positives. We are trying to optimize it uh, by introducing some algorithms which are new to us and we are currently learning. And yeah, in the phase 2 of our video, I would like to discuss about the critics as mentioned in the script on the website. So yeah, first of all, I would like to tell you about the section of GRAM. Maybe in my research, what I thought is uh, the GRAM work is soiled into the model, and the issue comes that model can be switched off at deployment, right? So what I was thinking about is that, so in the GRAM, I say that we are restricting or we are getting the model from the knowledge, right? But we are not stopping it from deriving the knowledge or deriving the fact, right? So what here happens is if you are giving it access of the lab of chemistry, all the procedures, then it may go and derive it for itself. And here what thing happens is you are just stating if it is a fact or not, but you are not checking if the data is spared redundantly. That redundant data can be help for the ungated model to learn or to derive the fact, right? So this is where I think we are going wrong. And also the other thing is that we are trying to refuse our own proposal. Like I have seen your one of the paper. It says that if your model is like into the uh, without reasoning, it tries to answer, let it be a positive or negative. If it is not giving reasoning behind the refusal, then your model is weak, your model is structurally weak. If we just say that okay, our model is perfect and it is giving no data mishaps, that means our model is taking the data or it is leaning from the neighboring tasks. There should be a drop in the performance if you are just removing the gated GRAM model. But if it is not showing any performance drop, that means your data is leaking. It is leaking from another road. possibly. So yeah, this is where I think we should work upon, and it makes me like bit curious about to learn how the structure works, because I seen this paper proposes a promising evaluation criteria, which I would like to work upon. If you say if the model turns out to be right and my approach might be need some trimming, I would like to work upon it. But yeah, let's see how it goes. Thank you, and that was from all my side. Thanks.